question 7. So figure 7.1 show a reaction scheme. It start from this compound U, and it's undergo a few reactions, total 6 reaction. And let's see what is the reactions about. Okay, so first, the compound U will undergo the reaction 1. Is from this carboxylic acid. Okay, so we still don't know what is the U. So we can use the reaction 2 products here, the primary amine. So because it's using the lithium aluminum hydride, so it's a reducing agent, and the amines form, which means the compound U is this ethane nitrile. Okay, because ethane nitrile add 2 hydrogens on the nitrogen and add 2 hydrogen on this carbon, so it will form this primary amine. Okay, so we know that compound U is ethane nitrile now. So ethane nitrile then will undergo the reaction 1. Now we know that this is a hydrolysis, because hydrolysis of nitrile will give the carboxylic acid. So in this case is the ethanoic acid. Then this ethanoic acid will undergo the third reaction. Okay, so it will undergo this third reaction with SOCl2. This SOCl2 it will form the acyl chloride. Why? Because the OH will be substituted by the chlorine in the SOCl2 to form this acyl chloride. Okay, so this is the ethanol chloride, CH3COCl. So this one, after that, it will undergo reaction 4 we'll discuss later. Okay, after reaction 3, so means from carboxylic acid now form acyl chloride. Now the acyl chloride means the compound V will combine with this primary amine just now. Okay, so this amine with this acyl chloride, it will form the amide. So this one actually is the lone pair on the amine, this nitrogen. So we'll attack this carbon, this partial positive carbon. So eventually it will form this the amide. Okay, so this one we can say that is a substitution. So because at the end the chlorine will removed, and it will form this hexia. Okay, so for this reaction 5, we can say this is a substitution. Actually, is one of the addition elimination reaction. Okay, after that it will form this amide, and amide will undergo this reaction 6. Okay, so look and compare carefully for this compound and this compound. So from here we see that this CO double bond, right? So this the oxygens removed and 2 hydrogens added to the carbon, so to form this secondary amine. Okay, so this one is obviously a reduction because it's remove oxygen first and add 2 hydrogen, right? So it's confirmed reduction. So how about reaction 4? So the primary amine now with the compound W form this secondary amine. So roughly we know that it should be a halogenol alkane with 1 ethyl group. Okay, it's actually similar to the reactions of this. Let's say we have a bromoethyl or bromoethane. So this bromoethane with ammonia, so it will form this primary amine. So this ethyl amine or ethane amine. So this one with HBr. So again, when we use a bromoethane with the ammonia, so it can form this primary amine with HBr. Okay, if let's say this bromoethane react with this primary amine, so the reaction is very similar. So the ethyl group will, okay, one of the hydrogens here will change to the ethyl group. It's just like this. One hydrogens here will change to this ethyl group. So now for this primary amine, after it's react with this bromoethane, also it will form this, okay, this secondary amine. Okay, I hope you understand and you can see that. So this is all the relations in this scheme. So if you understand, then you can answer all the parts here. Okay, so part A, identify compound U. So I told you just now, compound U is this ethane nitrile. So you can give the name or you can give the formula. B, describe the reagents and conditions for reaction 1. Okay, reaction 1 is hydrolysis. So because it's carboxylic acid, so we use the acid hydrolysis. So you just need to put the H plus aqueous heat with reflux. Part C, identify compound V. Compound V is still correct just now. Here, ethanol correct. CH3 COCl. Okay, so you can give this or this. Yeah. So the equation is this, right? Actually, this is the same. Complete equation for the reaction 3. Reaction 3 is this one. From this carboxylic acid form acyl chloride. So carboxylic acid with SOCl2, so it will form acyl chloride. Okay, one chlorine will combine with this H, form HCl, and the O here, right, it will combine with the SO to form SO2. Okay, so this is the equation. Identify compound W. So I told you already, it's a bromoethane because the primary amine here, right, so it needs to have another ethyl group. So one of the hydrogens here replaced by one ethyl group, so it must react with the bromoethane. So this ethyl group in this bromoethane, okay, can get into this amine, right? Okay, so now the part F, describe the conditions for reaction 4. Reaction 4 is okay, when we use ammonia in ethanol with this halogenol alkane, is always heat under pressure. So same thing when we use a primary amine with this bromoethane or halogenol alkane, also need to heat under pressure. Okay, that's the conditions. Heat under pressure in ethanol. Okay, G, suggest the reagents needed for reaction 6. Reaction 6 is a reduction, I told you just now. And the reduction of amide, we only use this, cannot use others. This is only reducing agent, lithium aluminum hydride. Okay, now this H, complete table 7.1, okay, by adding the reaction number 1, 2, 3, 4, 5, 6 to the right hand column. Okay, each of the numbers of 1, 2, 3, 4, 5, 6 should be used once only, so I cannot repeat. So first one, reaction number 1 is again hydrolysis. Okay, so told you already, hydrolysis. Reaction 2 is actually this is this can be a reduction, but we can put it addition because this nitrile is at 4 hydrogens in there. Okay, it's actually an addition also, right? So and the second reaction done. Third reaction, this is obviously is a substitution. So the chlorine substitutes the OH. And number 4 also. Okay, let's check this one. Okay, hydrolysis done. addition done. So for the reduction, we can use reduction. We cannot put the second because it cannot repeat. So we don't put the this reaction number 2 here. So reductions in this part is just reaction 6. Reaction 6. Okay, this one. So we use the lithium aluminum hydride to reduce the amide to this amine. Okay, now for this hydrolysis done, addition done, reduction done, are substitution. So 3, 4, 5, they are substitution. Okay, the 3 already told you, so this is substitution. For reaction 4, it is a substitution reaction. So it's just like what you learned in AS. So this carbon is partial positive, so partial negative. The nitrogens in the primary amine, okay, is lone pair will attack this carbon, and it will substitute this bromine. So this is a substitution reaction. This one also I told you is a substitution, because the chlorine will form chloride and eventually combine with one of the hydrogens and form the HCl. Right, so this is also a substitution. So 3, 4, 5 is a substitution reaction. Okay, now the this part 1. Compare the basicity of this amide, okay, the secondary amine, and ammonia. So basicity, first we need to know, when we have a nitrogen compound in and it's a basicity, means we need to know how available is the lone pair. If the lone pair on nitrogen is more available, means it's more basic. So we know that the amide is less basic or least basic, because the lone pair on nitrogens, it cannot really gain proton. Why? Because sometimes this lone pair, it will delocalize. Lone pair will delocalize into this CO double bond. So it will form this resonance structure. So means the lone pair is less available, it cannot really act as a base. For the secondary amine, because it has 2 ethyl group, which is electron donating, so if you let this lone pair more available and is more basic. So if this one compared with ammonia, this one is a stronger base, because the lone pair is more available. There are 2 electron donating group. So ammonia no electron donating group, so it's weaker. So this is a trend. First, most basic is secondary amine, followed by this ammonia, followed by this amide. Amide is not really basic. Okay, so first you just mention what is a basicity. Basicity is depends on ability of the lone pair on nitrogens accept the proton or hydrogen ion. And after that, so you need to mention the most basic and the least basic one. So the most basic is the secondary amine, because what? It has 2 ethyl group and is electron donating, which increase the electron density of the lone pair or on the nitrogen. The amide is least basic. You just need to discuss about the lone pair which delocalize into the CO double bond, like this, which this lone pair delocalize into this CO double bond. So less available, less basic. Okay, that's all. Thank you.